The following presentation was recorded at the 2025 Southeast Linux Fest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linux Fest, visit www.southeastlinuxfest.org. Come join us next June.
Okay, that's more people than I was expecting for a talk. It's not about cloud stuff or automating things. Well, we're automating things, but not virtual things. My name is Leander Hutton. I am, among other things, a Linux user, system administrator. My background is actually in physics and astronomy. Technically, that's what my schooling and degrees are in. So I've been at this for a while. I started in astronomy as a hobby as a young teenager, preteen. So I've been at this a little while. We're just going to talk about some software solutions for like observatory automation and planning your observing runs, like star charts. If you want to make, if you're like me and you like the Boomer paper, you can actually make your own printed star charts. So like we do outreach and stuff, and it's handy to have a way to make and update printed charts just to hand people. And kind of some touch on some image editing a little bit. I tried to condense it down because I can talk a lot. But anyway, thanks for coming, and let's go on with it. So just a brief overview. Scientific computing has been Unix, Nix focused for decades. Equipment automation, not so much. So like the data reduction, plotting your light curves, looking at your spectra, it's like an IRAF. That's been around. Anybody remember those words, IRAF? No? Okay. Showing my age. That's been around for decades. Equipment automation has always been kind of a sticky point here, though. The professional observatory that I still do outreach at and that I did research at, all of their automation bits and bobs are on Windows because it was set up 20 years ago or more, and they still use, what is it, X10 for like the light power thing and stuff. So the funny thing is the controller card for the main telescope there is still an ISA, I think it's an ISA card, and it has to plug into a physical machine. So it's like a $60,000 grant to get the new controller that works on like USB. Anyway, so I'm going to talk about what solutions to these problems exist today in the Linux space and what's kind of lacking. So what are we trying to do? I am a certified actual astronomer. I actually have research paper that I was a joint author on. It's 15 years ago, but I'm still going to brag about it. Dang it, I paid a lot to go to that school. Anyway, but I still keep up with it. I work in outreach, even though my day job is in IT. I taught at this same astronomy lab here for a number of years. We have, I think it's 15 C11 telescopes up there that the students can use remotely. It's been taken over by someone else, and they're trying to update it a little bit. But back then, again, Windows based was the thing. So I have an interest in this, and I have some experience with it. To me, there are three things to talk about. Observatory planning. So you can't know what you want to look at if you don't know what's up there. So these are your things like charting, ephemeris, planetarium software that have kind of replaced the printed paper books you used to get about every 25 years. You remember they used to update those because the universe is moving around us, and so those charts get out of date, and they issue a new epoch. That's kind of gone by the wayside now with this stuff. Telescope control and imaging. So you can actually, with some of this stuff, set your telescope up, let it run overnight in the freezing cold. You can go to bed, and with some of the higher end stuff, at least in the proprietary stuff, I haven't found a solution for this in Linux yet. If you have a dome or a roof, you can set it to where cloud detector starts detecting clouds or moisture going up. Shut down the scope, you show it the dome, you don't have to worry about it getting rained on. That's kind of nice. Data processing. So mostly making pretty pictures if you're a hobbyist. So I'm going to talk a little bit about that. Like I said, this is not a new thing. Back in the day when I was starting out, we had IRAF, which is This program here, there we go. It was it was it's standard for data processing, getting light curves. I forget what the acronym stands for at this point. Dr. Gray, one of my undergrad professors, told me that if I learned how to use IRAF, it would add 10 grand to my salary. That was a lie. Anyway, but that was what was used. Python, NumPy, AstroPy have kind of replaced that these days. The other program that we used back then was something called XFM. That's still around today. It was like a semi-closed source program, but it would give you kind of what was up, what was coming up. Again, it's an ephemeris, like a charting program. So the first one I want to talk about today, you've probably all heard of, is Stellarium. This is the 800-pound gorilla in this space. It's got a web application. It's got a mobile Android iOS application. The mobile phone application is kind of neat because it'll read your accelerometer, and you can do one of these, and it'll tell you what you're looking at most of the time. These are great for education. We run these in the lab to get people kind of used to like a simulation of what the night sky looks like. We live in the Southeast. Humidity, rain, thunderstorms are all huge problems, and nowadays football lights. So sometimes you have to simulate it. It's great for that. It's very user friendly, so you can give it to a group of high schoolers or entry-level college kids, and they can mess with it. It's good for that sort of stuff. There is an Oculars plug-in for this, so if you have a telescope and you want to do like simulate, like say you can tell Stellarium, I've got a 10-inch telescope with this focal length and a 25 millimeter eyepiece, and it will simulate that in the view so you can get an idea. So if you have like a Dobsonian and you want to do star hopping, you get an idea of what you're looking at through the eyepiece, so you can recognize that pattern when you're out in the field a little bit better. It allegedly can point telescopes. It is finicky. I've never gotten it to work. There are other solutions for this that work better. It does, because it is like an OpenGL 3D kind of program, it does have heavier system requirements. It's not suited for remote operation. We'll talk about that later. When I say heavier system requirements, a lot of these automation things are ultimately designed to run on like a Raspberry Pi. So, if you've got a laptop from the last 10 years, that's heavier system requirements, right? So, I recommend it. And they do have, if you don't want to run it, install it locally, or you can't, they do have a web version now that you can just run in a browser. Again, that's really heavy. The one I probably use more often is Cartes du Ciel. It's French. I don't speak French. Anyway, but it's also just called SkyChart in a proper language. Any French people in here? Anyway, I speak some Japanese, but I do not speak French. So this does like a 2D star chart. So you can go and make like a old school proper flat paper chart with this, and you can point a telescope with it too. Again, you can have different zoom levels. You can have different simulate different fields of view for different atmospheric conditions and light pollution and whatnot. Again, if you have like a Dobsonian telescope or some kind of scope, you've got to point yourself. This is great because you can sit at your laptop and you can go, okay, so when I'm out, I'm going to look for these 3 stars here that are going to point in this direction. And then there's the little galaxy I'm looking for, because maybe it's not exactly apparent in your eye. It does make a nice looking printed chart. A lot of observatories that do, maybe not a lot, I don't know if it's a lot, but a fair number of them actually use this program to make the printed star charts for their outreach. So, you come up to the desk, you check in, and they give you a printed star chart. It may have been made with this program. Again, Mac, Windows, Linux, probably BSD. They don't have a web version. This is one of those small projects that's like one guy in his garage. He's French, but that's okay. K-stars. This is the one, if you're doing telescope automation, that everyone kind of uses. It is compatible with something called ND, which I'll talk about later. The ECOS control panel system is part of this, and it is like plate solving for alignment and a lot of auto guiding stuff, all in one package. It's part of the KDE ecosystem, hence the K. Everything's got to start with a freaking K. But it runs on GNOME just fine and all that stuff. It's pretty light on system requirements. It's pretty easy. It can run on a Raspberry Pi, so if you're using that as your automation computer, it'll work just fine. Again, it kind of fills that role a little bit better. So now I want to talk about interfacing with hardware and kind of some telescope control. In the early 1990s, Meade dropped the LX200 on the market, which introduced the little hand controller. That's the Celestron version, but the Meade one looks very similar. And all of a sudden, go-to astronomy was open to mere mortal with $3,000. Okay, so maybe not everyone, but it worked really crudely for the time. Anyone who knows Meade electronics knows that these are probably not the most reliable things on the planet. Celestron later copied them. Now we have Skywatcher, which is just Synta, and they are just mainstream everywhere. I mean, most telescope you can get $500 telescopes with go-to technology on them. Problem is, they're like VCRs. I don't know how many people understand that reference, and that they still use these ridiculous controllers from the 90s that are not particularly user-friendly, even if you're used to them. And if you're working with young people, trying to get them into astronomy, who are used to iPads and touch screens, handing them this, you might as well have just handed them a phone book. Like, they gloss over, they're not interested anymore. They're like, what is this crap? They did have rudimentary, Celestron and Meade did provide rudimentary Windows software for these things way back then. I do mean rudimentary. And some of the Stellarium stuff I've worked with will try to interface with these. Like, there's basically a layer on top of this. It kind of works, kind of doesn't. But again, it's not Linux compatible. I'm sure these are old enough now that you can run them in Wine okay. But we have better native solutions, I think, than this. And I'm going to talk about two standards today. So first on the scene, we have ASCOM, which stands for Astronomy Common Object Model. This was initially a Windows-only. I don't know if it started off as open source, to be honest, or if it became open source later, but it's open source now. It's really focused on synchronous-only local devices. So this is the thing that, you trundle your laptop outside, you plug it into your telescope, and you sit your butt in the cold at your laptop driving your telescope is ASCOM. The nice thing is a lot of manufacturers provided ASCOM drivers for their gear. So, filter wheels, mounts, pointing mounts, cameras and stuff have ASCOM support somewhat if it comes from the thing. There's a new version of ASCOM called Alpaca where they saw Indy take off and they went, oh, we should do that. Where it's open source, it uses the same kind of model as Indy. I haven't really experienced with that because I'm more in this camp. But apparently that is the new way of things. They still have some limitations to whereas Indy is more of a plug-in model and there's more kind of open source drivers for it. Alpaca, I think, still relies a lot on the drivers provided by the hardware manufacturers. Indy, on the other hand, started off life open source. It stands for Instrument Neutral Distributed Interface. So basically, it just talks to, it doesn't really rely on a specific driver from manufacturer. It just they reverse engineered some things and learned you can talk to these motors and stuff directly. The nice thing about this is a distributed control with a client server architecture. So you don't have to sit your butt at your laptop. You can have a remote host over a network and you can sit in the comfort of your room. I live in the mountains. It gets down to like cold there, very cold at night. So you can sit inside away from the mosquitoes and you can do your telescoping and you're observing from the comfort of indoors when it gets too much. Or if you need a break, you can just go inside. Most of the driver plugins are in the Fedora, Debian, Zuse kind of repos, your bigger Linux distributions. I'm sure Ubuntu, obviously, if it's in Debian, it's in Ubuntu probably. Arch probably too, who knows. If you're using Arch, though, you're probably too busy fixing your laptop to do anything else. Anyway, but they're there. They're readily available. We can talk about the ND model a little bit. So you have a client, just like a web browser. You've got a client here, goes over the network to an ND server, and a lot of times these are small, low-power computers. These Raspberry Pis have been pretty popular in this space, although lately those little N100 mini PCs have beginning to take off because you get a little bit more oomph for your dollar, but some kind of low power device. And then you get a bunch of USB to serial cables, and I'm not kidding about that. I have a Meade LX90 and it still uses a freaking serial cable, and it was made in 2023. But you can plug that into your telescope, you can plug that into your camera, you can plug that into your filter wheel. Again, if you have some other hardware that supports, as long as it supports it, you can use it. I know it's, like I said, SynScan from like Orion. It doesn't exist anymore. Neither does Meade. But Skywatcher is their other seller of their goods. Celestron stuff works great with it. I think if you've got enough money for a Mandy, this works with it too. But there's a database online you can go before you purchase gear or something. You can check if you want to use Indy. You can go in there and look and see what works and what doesn't. Personal advice: I really like the Skywatcher Synta mounts, and before that the Orion mounts, because they use a EQ mod, so you don't actually need the hand controller or the little serial cable. You go get a USB cable, plug it straight into the mount, and you don't need the like intermediate little hand controller. The Meade stuff, some of the Meade stuff and some of the Celestron stuff, you actually leave the hand controller and plug the serial cable into the hand controller, so it's just another bit and bob to get in the way. I kind of like those a bit if you want some purchasing advice. Good luck with that. All of those are made in China and are like $300 more expensive now. Anyway, so that's kind of the model. There's actually, you don't have to have an ND client on your remote host. You can have, just like how many people have done local development on a web server on their laptop. You fire up a web server and you start hacking away. The same thing here. You can have the ND server and the ND client on the same box and VNC into it. In fact, there are some solutions for that too. So you don't have to worry about ND going over your network and all of this stuff and SSL if you want to do that. Another thing I wanted to talk about a little bit. K-stars and echoes will handle your auto guiding, which is if you're not an astronomy person. So you line up your mount, it starts tracking with the movement of the Earth, but every one of these mounts has some amount of error in it, some amount of slop. And auto guiding, you put like a little telescope on top of your big telescope, right? And you put a camera on it, and what it does is look at a guide star and you put a box around it fundamentally, and it will use a computer program to look at that star in that box. And if that starts to drift too much, it can do some math, figure out which axis is off by how much, and then either speed up or slow down that. K-stars and echoes can do that as one, but there's another program that's been around for a while called PHD2. Literally stands for Push Here Dummy. It's pretty simple. It does have an experimental Linux build. It's really better suited for Ubuntu-based ones, but you can make it work on Fedora or Red Hat ones. It is ND compatible, but there are multiple auto guiding solutions, and that's kind of what I've been wanted to talk about, is that a lot of these programs that were with the rise of the Raspberry Pi and the fact that the Raspberry Pi, well, before the pandemic, was cheaper than chips, and you could get them and use them to automate these things. A lot of these vintage, we'll say, Windows-only programs. I don't know how many people are involved with like ham radio in here too, but a lot of these like old hobby and I would say semi-professional spaces are like, well, you spend a lot of money on your radio, you should use a proper operating system. I'm not going to port my software. But now with the Raspberry Pi in this space, a lot of these things are being ported to Linux now, and this is an example of that. It's a great little thing. It does one thing, does it well. This is very Unix philosophy. That being said, if you don't want to tinker too much, if you just want to use these products and work, they can be Cantankerous. They can, you're trying to get you're anybody who's worked in Linux long enough knows that if you're taking one thing that's written by one person, another thing is written by another, even though they're supposed to talk to each other with an open standard, good lord, they can break a lot. There are two kind of pre-built distros for Raspberry Pis and mini PCs that you can just go and get. Astroberry is free, is Raspberry Pi only. Downside is it's 32-bit. I think their image is only 32-bit. But, you don't need a lot of power to run these things. So if you've got an old Pi 3 or 4 laying around, you can hook it on there and do it. It uses a VNC client, so it's actually pretty neat. I've used Astroberry before, and you set it up, you plug it in, it starts broadcasting an ad hoc Wi-Fi network, and you take your laptop or your tablet, you connect it with the VNC client, and you can control the telescope from the VNC client. It launches all the programs and all that stuff. It's pretty neat. It works pretty well. Somebody was working on Astroberry and decided they wanted to professionalize it. Sound familiar? And so the StellarMate kind of fell out of that. StellarMate is a bit more up to date, a bit more polished, and whatnot. You can buy the OS from them for $60. Again, they're going the Red Hat model, just to say, they're taking free components, packaging them, and selling them for support and stuff. But they will also sell you, if you want something out of the box for free, they will sell you a mini PC with this OS and the stuff all set up for you for like $150, $200 or something like that, and you just plug and go. And it's got like a case, and it's got like the serial breakouts on it and stuff like that. So if you're not much of a tinkerer and you just want like an out of the box kind of works experience using this technology, you can do that. However, again, all of these are free open source programs. If you do want to download Raspbian OS, like Raspberry Pi OS, Astroberry is just based on that. You can apt-get install all that stuff, configure it yourself, and do everything you want. Just do everything you want for free on your own time. Let's talk about image processing a little bit. I don't have too much on this because I thought I might run out of time, but looks like I'm good. Serial. So Serial is a free program, again, available for Mac OS, Linux, and Windows. When you do astronomy imaging, you usually take, instead of like leaving a camera open for 30 minutes, you take 31-minute exposures and then you stack them in post. So this is what Serial does. You take your images, you take your dark frames, and you take your flat frames, and you point Serial at them, and it goes and it does all the stacking. It's a bit complicated. You kind of have to know a little bit about what you're doing, but you can get pretty good results out of it. Image must be converted. That's the thing. It doesn't really support camera raw, so like I still use a DSLR for a lot of my imaging, but images have to be converted to a 32-bit FIFITS file, which is kind of the international standard for the astronomy images. It'll do it automatically for you. CPU, it is kind of CPU intensive, RAM intensive mainly. I remember doing some Andromeda Galaxy imaging, and this was back in the 8 and 16 gigabytes of RAM days, and hitting RAM limits and crashing programs out. So, you need a machine with a little bit of lead in its pencil, but nothing too unruly for these days. And it's great. Again, if you're not a Linux user, you can totally use this on Windows and Mac OS. I use it. I do have a MacBook, and I do use it on there sometimes. But again, it's made a lot of strides, because back in the day, your options for doing this, especially as a low budget hobbyist, was Mira or Deep Sky Stacker if you were kind of cheap, or PixInsight. And PixInsight has a Linux and BSD versions, but PixInsight also costs $160 and only supports a limited range of things. This is compiled and lives in the repo of your OS probably, and it's an apt-get or a DNF install or a pacman break everything to get it installed. But so we've really come a long way. Now I'll just show you some results here. some of my stuff. So, that's a stack of images of Saturn. This was actually done in the GIMP. That was of the total lunar eclipse. This wasn't a stack, obviously. I just put it in there. But I did use Linux to do this. This was made in the GIMP of the recent solar lunar eclipse. And then this is out of Serial, so you can get pretty good images. You do need to spend some time kind of tinkering with it and looking at settings, because there's different transforms and all this other stuff to get more contrast out of it. But this is actually, so this was just with a 70 to 200 millimeter lens, and you can see, can't see it too well on the projector, but you got the flame and the horse head. And the horse head, you can't even see with your naked eye. Like, I have a 12-inch telescope and I can't see it, but you can get it out of your images here. And again, this is all done with free open source stuff. Yeah, so I really think it's come a long way. Yes, that's at the 200 end. So f4, then the bad thing about using camera lenses for astronomy is that camera lenses, particularly fast ones, tend not to correct for chromatic aberration and astigmatism too well. So you really need to stop it up to like 4 or 5, 6. You're looking at an astronomy telescope and it's like, oh, f5, f7, that's slow. But then you get your f2.8 out and you point it at the stars and you get the blue halos and the skid marks and all that stuff and the stars that look like a comma at the edge, and you're like, okay, that's why those are that slow, because they're well corrected. But yeah, so you could do basic stuff. I recommend looking at Optron makes a sky tracker. I have the Skywatcher Star Adventurer little mount. It's AA powered, or you can plug in a USB power bank to it, and it's heavy duty enough for like a modern mirrorless or DSLR camera with a reasonable lens on it. If you are, I really like the Skywatcher mounts if you want something to hold more stuff, like the HQ-E5 or the HQ-R6. Look at the prices and realize 6 months ago those were $300 cheaper. Not to get on my soapbox here. Celestron makes one, the AVX, that can hold a reasonably sized telescope. I don't like that one as much because it's got a bushing on the deck axis instead of an actual bearing, and so it's kind of one of those things where if you get a good one, it's great. If you get a bad one, the Skywatcher has a little bit better control, quality control. But yeah, there's a lot of options. There's for kind of getting started, and I do recommend, if you want to start with this, don't go out and buy don't go buy an 8, 10, 12 inch 2000, 2500 millimeter focal length Schmidt-Cassegrain telescope. You're gonna go crazy, because you're gonna need auto guiding for that. It's heavy. You're gonna need a heavy duty mount. They are slow. You're gonna need focal reducers. Go buy yourself like again, now $300 to $500 80 millimeter. They were $200 to $300. 80 millimeter refractor, like with ED glass or something in it. That's inexpensive. It's got like a 500 millimeter focal length on it, and start with that. You can do a lot of wide field imaging with that. A lot of things in the night sky are bigger than the full moon. So the full moon's kind of small, but they're just faint. So like the Andromeda Galaxy, the Orion, Rosette Nebula kind of stuff there's a lot of nebulosity near Sagittarius that you can just use a wide field refractor 2 degree and get some nice images out of. And you can use it for visual too. You can take the camera off, you can put a eyepiece in it, and you can look at things with your naked eye. Unfortunately, the moment of my soapbox, teach, and I saw this when I was teaching too, is that we're dealing with generations who have grown up with Hubble and James Webb imagery. And so, you get your kids out there and they're like, faint, squiggly. What are you? I'm going to go back and play Fortnite. If you do have a kid and you aren't opposed to proprietary stuff and you want to keep them interested in it, the C-Star line of telescopes are smart telescopes, and I hate them because they don't have an eyepiece. They're smartphone only, but you plunk them down. You can image with your phone. You take, and it does all the stuff Serial does, but like in the computer, on the telescope, or on your phone, and you can start imaging right away, and you get color, and you get like that squiggly line then becomes a thing with definition and detail in it. I don't really care for those for a number of reasons. One, they tie you to a proprietary app. They tie you, it's more screen time. I hate these nightmare rectangles. When I retire, this is going straight in the bin. But it's for engaging young people at outreach. It's probably, I mean, it's when I do outreach at the observatory, we had a student who bought one of these. They didn't buy the C-Star, they bought the EV scope. And it was like, I have a 12-inch Dobsonian that I take out there, which is, if you're familiar with telescopes, that's absolutely massive. It used to draw a crowd because they're like, that's big. And nobody was interested in that. Everyone was looking at the smart telescope because they could hold their iPad and go, you know. So that's just the way she goes. But anyway, yeah. But I would, if you do want to get into this stuff, I'd recommend looking at, you can look at some smaller telescopes. And smaller telescopes means you need a smaller mount, means you're in it for less money, and it's just easier to work with. You don't really need to auto guide. You can get some pretty impressive stuff on your first. You can go out in the wintertime and do the Orion Nebula, and you're like, wow, that was not that hard. And then you can kind of step up to bigger equipment or harder targets and stuff like that. I guess I'll leave some time for questions. I made it to 30 minutes, so I've yapped enough. If you have a question, please use the mic and he'll get it to you. Yeah, that dude back there.
Testing. Can you hear me?
Yeah, I can hear.
I don't know the term for it, but what light pollution, like that image of Horsehead?
Yeah.
What light pollution? On what border scale was that image?
That was taken in my front yard, and I think we're like at a Bortle. We're pretty good. I live in Todd, North Carolina, which is out, and I think we're like a Bortle 3 or 4. We're not bad. We're not like 1 or 2, but I can see the Milky Way with the naked eye in my front yard. So yeah. That's another problem. That's a good point about the light pollution is now that we're switching to the more energy efficient LEDs and street lights, it's kind of a twofold problem. One is the old sodium ones were red and you could filter them out. The new ones are blue, harder to filter, and they're also brighter. Cities are like, okay, well, we can still run it at 1,000,000 watts and get 1,000,000 lumens out. Anyway, so any questions? Somebody else? Guy in the Pixies shirt.
Hey there.
Hello.
I just wanted to ask if you've heard of a project called Astroterm. It's on GitHub. It's like a star map it renders out to like ASCII characters in your terminal.
Oh, I think I've seen that. I wasn't familiar with the term, but yeah, I think I've seen that.
Yeah. I just thought I'd mention it because it looked really cool.
It is really cool. Yeah, I've seen that. It's kind of more of a novelty thing, but yeah, it is neat. Yeah. But yeah, I've heard of that. I don't wasn't familiar with the term, but yeah, I've seen that before. If you want to render, if you're good with command line stuff, there are some Python libraries for rendering star charts, so you can play with that too. Yes, dressed up in the tuxedo man.
As far as the older the Meads and stuff, I bought a Mead Star Navigator in NG 125, I think, back in 2019, and as you said, the little hand controller never worked. The motor was junk from the get-go. We sent it back, and we now have much to your chagrin, a C-Star S50. And even though I live in a suburb of Nashville, we're able to get a good bit of imaging with that. Plus, as me and my wife are both older, with the telescopes like you have, sometimes it's hard to bend over and look through the eyepiece and align it and everything. So just sitting in the living room, doing it on the little square demon box is not such a bad thing sometimes.
Yeah, there's accessibility things there too. That's another thing. So I am into big scopes because I am 40 years young and I work out and lift weights, and so like a 70-pound mount and stuff for me is just whatever. That's why I tell my wife when I buy new stuff and it shows up at the door, I'm like, I've got to do it while I'm young. In 20 years, I won't be able to lift this stuff. But yeah, that's definitely I don't care for them for a number of philosophical reasons, but for a practical tool for young people and old and older people who are maybe not who are interested but are not able to lift heavy equipment, they're fantastic. For me, it's the proprietary software and the e-waste. a decent optical tube will last your lifetime. I just restored a 1981 Meade Newtonian that, it'll outlive. I'll probably sell it to somebody in 20 years and it'll keep going. These C stars, when they stop making the apps and the servers, they're garbage. So, any other questions? This is a bigger crowd. I appreciate it. We talked about automating things that aren't web servers and things. So hopefully we learned some stuff, and appreciate you coming out and everything. Thank you. Oh yeah, the Windows XP with the pug. Yeah, I have a bunch of Mimi desktops, so